everybody. Thank you so much for joining us today. We have a very exciting conversation coming up. So as we get started, my name is Kalia Garrido. I'm in charge of events and marketing here at Great Data Minds. Just a quick bit about us, if you haven't already heard. So Great Data Minds is a collective of passionate data activists. We are on a mission to modernize the world of data. We have a range of services around data, from strategic planning, education, deployment, and just kind of all facets of critical data projects. And so we also produce a lot of great content in the way of events just like this, in which you can listen in and see recorded video sessions, or read a white paper or read a chronicle that we have. So if you'd like to be on our list to make sure that you don't miss any of the new content that we have coming up, just go ahead to greatdataminds.com. We've got a newsletter, sign up there. One upcoming don't miss session that I want to mention that we have coming up is a multi-day executive level workshop. Now, this is going to start on June 10th, and it will provide you with the real deal how-to for standing up a modern analytics program of your own. And so make sure you check that out. If you want to see that or other events that we have coming up, you just go to greatdataminds.com/event, and you'll find everything we have there. So let me introduce today's guests. We have one of our usual suspects. Mike Lamp is with us today. He is one of our stellar Great Data Minds advisors, and he's a certified SAFE program consultant. Mike has been busy just for the last few decades or so, transforming enterprise analytics programs to increase relevancy and enhance value in a thriving digital age. And our very special guest today is Mr. Dan Galavan. He is a senior cloud data architect consultant who has been delivering data solutions for clients for about 21 years. He specializes in data architecture, solution design, development, and management for small to medium corporate clients. He's an associate faculty lecturer at the National College of Ireland and one of Ireland's leading data solution experts. He is based in Dublin. He provides consultancy services to the clients in public, financial, and health sectors. He's also a graduate of the National University of Ireland, Galavan, and he holds a Bachelor of Science in Information Technology. To find out even more about Dan after this conversation, you can always take a peek at galavan.com. That's GALAVAN.com. Guys, welcome. Thank you so much for joining us today. I'm excited to hear the conversation.
Yeah.
Thank you very much.
Hey, Dan, how are you?
I'm good. How are you, Mike?
I'm doing great. All right.
Good.
So let's see. I think our topic today is something around graph or something about Kevin Bacon. Right? Yeah,
yeah, that's
sure.
correct.
Yeah. So what is this graph thing? Tell me.
Yeah, sure. So it's graph databases and graph analytics. So they're all based around the concept of data graphs. So in its most high level sense, a graph is made up of two parts. Mm-hmm. You've got a vertex or a node, and that's like a data point at a very high level, and then there's associations between those nodes. They would be referred to as edges or relationships. So it's really about, obviously we're talking about data, right? But the emphasis is on how the data is associated. What are the associations between the data? So if you look at the different types of NoSQL offerings and even relational databases, they have different levels of emphasis on how much interest they have in the associations between the data. So at one end of the spectrum, you've got key value pairs. You're just interested in what's the value associated with the key, right? Document, you're interested in hierarchy, relational databases. Yeah, you're absolutely. And by the way, relational databases, they're called relational because of relational algebra. It's not because of the association. Well, it's in a roundabout manner, but technically speaking, right? And then if you're very interested in the complex relationships, if you know those many-to-many relationships in relational data, if you've got lots and lots and lots of those, then you're into the graph database and data graph space.
Oh, yeah, sure. Yeah, because those many-to-manys in relational, I was always breaking them down. and putting an
Sure.
associative edit in there. So cool. So that gives me a decent feel for why and when to consider a graph database as an applied technology. Yeah.
Sure.
So I was hearing a lot about graph databases a bit
Mm.
ago.
Mm.
Can you talk about that a little bit?
Yeah, so I mean, well, again, going back to the relational database versus graph. Relational, they've been around for 40 plus years. Oracle came out with a commercial offering in 1979. Graphs are relatively newer, so they're less than 10 years on the scene.
Mm-hmm.
So there's still a level of evolution. Again, comparing it to relational, relational has been around longer, and there's more standardized and all the rest.
Sure.
So a good way to articulate this is have you heard of the website DB Engines?
No, I haven't.
DB Engines. So these guys monitor trends in terms of data, right?
Mm-hmm.
So they look at what's hot and what's not in terms of
Okay.
databases.
Uh-huh.
And they look at what's being discussed on LinkedIn, job offers, Stack Overflow, what kind of questions, Google Trends, and all the rest. So they look at trends. And if you look at the trends in terms of databases, so since 2013, you'll see relational databases. The trend hasn't really increased, but it hasn't decreased.
Mm-hmm.
But if you look at the relative trend of interest in graph databases, particularly certain types, it's gone like that, okay?
Interesting. So
relatively speaking, there's been a lot more interest in graph data and data management in certainly since 2013. Mm-hmm. So that could feed into what the fact that you've heard more relatively recently about graph databases.
Mm-hmm. Okay, interesting. Yeah. So what kind of use cases are more applicable for the capabilities of graph databases?
Ooh. The right tool for the right job, right?
Yeah. Okay.
Okay. Look, as any consultant will tell you, it depends, right?
Of course. Yeah.
So it depends.
Make a lot of money saying that.
So it depends obviously on the use case, but the most important thing is actually that you know what the use case is. What do you want it for? I mean, there's been a bit of hype. There's been if you look at, the graph, the Gartner Magic Quadrants.
Sure.
The Gartner Magic Quadrants, right? And they also have the Gartner hype cycles.
Yeah.
Graph databases have gone from the peak of inflated expectation down into the trough of disillusionment, right? Mm. And it's first, one of the reasons for that is the use case. Everyone is talking about graph databases.
Yeah,
we got to get one. Get me one, right? It's a bit like data lakes. You need to be clear about why you want it, what's the specific use case. Now, if you identify that, then you're going in the right direction, right? You potentially are. Mm-hmm. So use cases could be, I'll give you 3.
All right.
Fraud detection, fraud ring detection, right? So you've got like maybe insurance fraud or credit card fraud. If you can use graph databases and graph analytics to pick up on anomalies, like let's say the same, lots of different accounts, like trading accounts coming from the same IP address, or if you pick up on this, you can say, well, you can apply different algorithms. Like there are community detection algorithms to see, well, who's associated with, I think there's some fraud going on. What's the association? Mm-hmm. There's a keyword, right? Mm-hmm. Association of data. That's the emphasis for graph databases, actually. Mm-hmm. So who's in the ring? Okay. Mm-hmm. And then you can apply other algorithms like, have you heard of the PageRank algorithm?
Oh yeah, for like what Google does. Yeah.
Exactly. You can use that algorithm with graphs, and you can work out in fraud rings who are the key players here, right? Mm-hmm. Another use case would be network and asset management. Like, network switches.
Mhm.
You want to work out what's the single point of failure, what happens with that single point of failure. And this is where graphs are really powerful, because if you've got a network and you're trying to work out what, you don't necessarily know how deep in hierarchy the network is, or how wide it is, right, in terms of levels.
Mhm.
That doesn't matter for graphs. If it's a relational database, can you do that? Yes, but you're looking at recursive queries. Is it going to time out? They're not optimized for this type of processing, but graph databases are.
Mhm.
And a third use case would be, at a high level, COVID-19 tracing,
Yeah,
right?
I was just thinking contact tracing. Yeah.
Absolutely. But, there is a but, which is, it's like any kind of data exercise. It's only as good as the quality of your data.
Mhm.
So if you've got a contact tracing data set, but only 10% of the population have contributed to this, it's only going to be so useful, right?
Mhm.
Depends on the quality of your data. So they'd be the use cases. Oh, you mentioned Kevin Bacon.
I did.
Would you like to discuss that further?
I would.
I would. I'm sitting here. I'm sitting here like, okay, what does this all have to do with Kevin Bacon?
Yeah.
All right. So you know the 6 degrees of separation, right?
Of course. Yes.
And you know the Hollywood the 6 degrees of Kevin Bacon, right? Where Kevin Bacon said, I reckon that I've worked with so many people in Hollywood, I'm connected with everyone. So there's that board game that says, within 6 degrees of separation, Kevin Bacon is associated with everyone in Hollywood. And that's the key word here, association.
Oh, I thought it was bacon.
I would put that equally as high in priority, of course. Yeah, I agree,
Sure.
right?
Awesome.
But you can use, like, if I can actually show you a very quick demo, which, yeah.
Yep.
Which it'll help to articulate, what graph databases look like, and looking at the Kevin Bacon problem from a graph database perspective. Not the Kevin Bacon problem, but the Kevin Bacon association, right?
Okay.
Are you ready?
Yes, I am, sir.
Okay. All right, here we go.
Come on, technology.
Oh, I just need to share my screen. Just one moment. And the type of, this actually opens an interesting graph database type discussion.
Mm-hmm.
Can you see my screen?
Yes, sir. We sure can.
So can you see database information in the top left here?
I do.
Oh, fantastic. Okay, good. All right, so this is one of, the demo I'm going to show you is, there are two main types in the market right now. And this is where you need to, depending on, again, the use case and what you need to do, there are two main types. There's property graphs and there's semantic graphs. They're also known as triple store graphs.
Okay.
And they have different strengths. They will both, let's keep it, for the purposes of this conversation, the takeaway point here is there are two types, main types of graph databases in the market at present.
Okay.
So semantic triple stores and this type, which is property graphs, okay?
All right.
And on the left-hand side, you can see here, I've got obviously properties and I've got relationship types, they're the associations, and I've got node labels, and these allow me to classify or categorize the edges on your graph, okay?
Mm-hmm.
So the first thing we want to do, we want to check, is Kevin Bacon in our data set, okay? And that's what we've just done here. We've just checked. I mean, right now, relational database and graph, they're neck and neck, okay?
Mm-hmm.
There's not that much of a difference in terms of what we're doing here. We've just checked, does Kevin Bacon exist in the data set?
Mm-hmm.
And now we want to do a little bit more in terms of the power of graph databases. What movies has Kevin Bacon acted in, right? And this, again, is in terms of how good is your data set. So within this data set, we can see that Kevin Bacon has acted in 3 movies. Can you see my screen okay? Should I zoom in?
I see it fine.
You see it?
Yeah, looks good to me.
Okay, great. So within this
Just a little
data set.
distracted because my dog's trying to bark.
Okay. And in terms of what is a graph, a data graph, these blue and orange spots, they're the nodes or edges. And these lines here are obviously the associations. Nodes are vertices, should I say, are the blue and orange. And these lines here are the associations or edges, okay? And now we're going to take a little step further and we're going to work out who within this data set has Kevin Bacon directly acted with, okay? And again, what to note, there's two things to note here. If you look at the query, it's still light. If you compare that to how you might write this in SQL, this is still relatively light. We don't need to go into the syntax other than to say, look, I've picked out this very in a very straightforward manner, which actors in this data set have acted with Kevin Bacon, okay? So I can see here in Apollo 13, Bill Paxton, he's represented as an edge. Sorry, I keep getting a node or a vertex. Ed Harris is represented as a node or vertex. Gary Sinise and Tom Hanks, okay? And the center node is obviously movie. So they're categorized using labels. This is actually technically an LPG, a labeled property graph. Okay. The next one we want to do is we're going to use a graph algorithm. The algorithm is called shortest path, and that's to work out, as the name says, what's the shortest path between two different actors in Hollywood. And in this case, we're going to look at Kevin Bacon and Meg Ryan. If I'm going to look at the association between Kevin Bacon in Hollywood and Meg Ryan in Hollywood, okay, what's the shortest route to them? Because I'm sure there are lots of different ways you could associate both of those actors, right? And again, that's a pretty light piece of code right there. And it's picked up that the quickest way to associate Kevin Bacon and Meg Ryan is through Kevin Bacon acting in A Few Good Men, and Tom Cruise also acted in A Few Good Men. He acted in Top Gun, of course he did, great movie. Top Gun 2, I believe, is coming out soon. And there's the Meg Ryan association.
There you go.
So exactly, so we've used a graph algorithm to traverse the graph. It's done a recursive traversal.
That would have been challenging relational.
Exactly. The deeper the schema. Oh yeah, of course. And the deeper the graph, the more complex the recursion is. But for graphs, because it's actually to do with the storage of the data under the hood, this is bread and butter for graphs. Now, are you ready for the grand finale? Right. The 6 degrees of Kevin Bacon. Mm-hmm. Here we go. Check out the code here, by the way. I'm asking the graph database to tell me the 6 degrees of separation for Kevin Bacon in Hollywood. It's still the same. I haven't had to make it more complex or anything like that. And we have a look at it here. And voila. Okay. It's picked up on.
Holy cow.
Yeah. So you can see. But this is bread and butter for a graph database. So you can see the circles, the nodes are vertices, the lines are the edges or associations or arcs. And it's also very intuitive, right? If you compare this to a relational structure, a complex 3 and third normal form, an end user will find this more intuitive to interpret. And you're not necessarily going to show this to an end user, but if you did, you could, of course you could. They're going to find it more intuitive, right? And there's the man himself, Kevin Bacon. So that is a very quick demo as an introduction to graph databases. Any questions or thoughts so far?
Well, I'm loving the ease of the user interaction there.
Sure.
You know, even though that looks a lot like code, it looks like pretty simple code.
Absolutely.
And any business analyst that's familiar with SQL, I would suspect would pick up on being able to interact with the content in the graph database quite easily. Yeah.
Absolutely.
Yeah. Cool. So, sensing the underlying concepts could have a wider use than storing data in analytics, right?
Mm-hmm.
I mean, if I looked at, you said before, it's not a one size fits all kind of thing. You know, you want to use graphs where graphs are best used. And, the first thing I think of is, well, I want to do some complex queries to do some analytics. I could do that, but it's feeling like it could have some wider application around an analytics platform than just storing the data I'm going to do analytics on. Am I
Oh,
onto
absolutely.
something? Yeah.
You're onto something, right?
Yeah.
Here's the thing about graphs. All data can be put into a graph. That does not mean that all data should be put into a graph, right? Mm-hmm. You know the law of the hammer?
Mm-hmm.
If you have a hammer, everything looks like a nail, right?
That's right.
And there's a cognitive bias there. If you have a relational database, you may have a tendency to try and, okay, I'm going to try and do everything in a relational database. That's where my skill set is. That's the space I'm in. I've got the infrastructure. And the same applies to graph databases. If you have a graph, if you have data that can fit in a graph, mm-hmm. you could be forgiven for thinking, oh, I need a graph database, right? So there are use cases where graph databases are good, and use cases where graph databases not so good. Okay.
Give me a couple of examples of good ones.
Pardon?
Give me a couple of examples of good ones.
Oh, of course. So the ones I mentioned, like fraud detection, information, network asset management, COVID-19 tracing in principle. Other ones would be identity and authentication management in terms of permissions on folders in networks, right? Mm-hmm. Recommendation engines can be good, but it depends on the engine. It depends on how complex your product catalog is, for example. I mean, there's a discussion about master data management, for example, right? Mm-hmm. And of course, you're interested in the hierarchy of your data, but a graph database is not going to solve your master data management problem. Mm-hmm. So could you use a graph database to augment your master data management processes? Yes. Is a graph database or graph analytics the panacea that's going to solve your master data management problem? No, it is not.
Okay. All right.
So it really depends. I mean, and another one where it's a potentially really good fit, it's still evolving, is around machine learning, because a lot of the like neural networks, mm-hmm. they're graphs, right? But the typical inputs are relational or flat or denormalized.
Uh-huh.
So there's a bit of potential there in terms of could you use graphs as inputs into the likes of machine learning algorithm processing. Oh, there's another thing to mention as well. We've talked primarily about graph databases, and we did touch on graph analytics. You don't need a graph database to do graph analytics, right? Mm-hmm. You can, if you've got a graph analytics engine, you just need to import it from somewhere else and process it there. So on the market, you can get graph databases that are property graphs, that are semantic triple stores. You can get graph databases that do both. You can also get graph analytics engines that will do the processing separately from your source data. So there are different options on the market as well. Okay.
Mm-hmm.
That makes sense. Yep.
All right. So give me the three key things of goodness that I could expect from taking advantage of graph databases or graph analytics?
Yeah, sure. All right. Number one is the association between the data, right?
Uh-huh.
If your focus is on the associations between the data, and they're complex, and there's lots of them, and there's lots of levels, you do know how many levels, graphs definitely worth considering. The
And
second
it would
thing
allow
is
me to keep adding levels too, relatively easy, right?
that feeds into the second point. That's a really good observation there.
Okay.
Graphs are really flexible. So with relational models, of course you can change them, but there's an overhead to them in terms of what happens in other parts of the model. With graph models, they're much easier to add pieces onto. So the second thing would be flexibility in terms of graph data models.
Okay.
And the third one I would say I would give in terms of keeping it to 3 is, as I said, in intuitiveness, right? They're relatively easy to understand. And that's a big benefit in terms of introducing a broader spectrum of users.
Yeah.
Now, there's one thing I need. Sorry, yeah, go ahead.
Yeah, I'm sorry to interrupt, but
No, it's okay.
Especially when it's solving a very complex association problem, right? Which is hard for a head to get around, So
yes,
for them to have an easier interaction model to the end analyst on a complex problem is very cool.
Yes, indeed.
I'm sorry, you had another point?
Yeah, I feel obliged. I think it's important to mention cases where graph databases and graph data is maybe not so suited.
Okay.
Okay, I got a list for this as well, right? So number one is if you're just not, it's almost like a flip on the list we just went through. If you are not interested in the associations, then graph databases are not the right choice. Okay. If you're just interested in key value pairs and what the values are, and that's it, graph databases are not for you. If you're working with, blobs, binary large objects, but large pieces of data, probably not graph databases. They're probably not the right answer. If you have a very simple model that does not change, right? Maybe not graph databases or graph models. And if you're doing aggregations, for example, I mean, can you do aggregations in a graph database? With a lot of the vendors, yes, of course. Are they the best option? You're looking at something more like perhaps, depending on the type of aggregations, a columnar store, data warehouse, right? Some kind of a distributed solution like that can really handle that kind of workload. So it really depends. It comes back to, it depends. It depends on the use case, what you want to get out of your data. And that will help to inform you in terms of the right path.
Great. Well, Dan, very informative. To tell you the truth, I did not know anything about graph databases and graph analytics until I had this informative session with you, and I so appreciate that, sir.
You're welcome. It's my pleasure.
Yeah, my pleasure to interact with you. Thank you. Kayla?
Yeah,
okay.
I appreciate the real world example because like as the not quite as technical girl on the block, that was very it was cool to see it out like that, like the true 6 degrees of separation for sure. Nicely done, Dan. Nicely done.
Thank you very much. Thanks, guys. Thank you. You're very kind.
Yep. Thank you, everybody. So if you want to have some more information, either from Great Data Minds or from Dan himself, you can always find us at greatdataminds.com, and Dan can be reached at galavan.com. And we wish everybody a wonderful day. Be healthy. Be well.
Bye.
Thanks, guys.
Bye-bye.
Take care. Bye-bye.
Bye-bye.